Hello students, so today also we'll be continuing with the function chapter. So in continuation of the previous video where I discussed the scope rules of variables, there I discussed about local variables. So we shall continue with the scope rules of variables. Okay. So just a recap of the previous video. Scope rules of variables implies how different parts of the program can access the variable. Normally when a variable is declared in a function, it is accessible only in that function body. So we have seen that. So four types of variables is used. Local variables, so you can check the previous video if you have not watched that. Okay. Then today we'll discuss about global variable, formal variable or formal parameters, and actual variable or actual parameters. Okay. Under that we have the formal arguments and actual arguments, or like that. So number two is global variable. So global variables are declared before the main function at the beginning of the program. Okay, so before all function definitions. So this global variable is declared after the header file. Okay, just before the main function starts. Clear? So this is used by all the function definitions, by the main functions also. Okay, so this a global variable is accessible to all the functions, to the main function, to the function definitions also. So it is visible to all functions and is declared outside all functions, not inside any function but outside of the functions. So unlike local variables, they hold their values throughout the execution of the program. So as long as the program is running, the global variable, since it is beyond the any functions, okay, so as long as the program runs, it will hold that value in that variable. But in terms of local variables, okay, since it is constrained to constricted to a certain block only, block function body only, okay, so as long as that function body is executed, uh, once that function body is terminated, okay, the local variable will cease to exist. So here is an example. So you can see that int a, this is declared after a header file, so this is a global variable. Now in the main function I have declared the same variable a, but this a and int a are not same because this is a local variable. So this a is a local variable which is used only in the main function. Now this global variable a, it can also be used in the main function provided it is within a different block, or it can be used by other function definitions also. Clear? So based on that, okay, we have a program. So here it may be sometimes that the local variable and the global variable could have the same name, the same variable name, the same data type inside of in the function program. So then the local variable hides the global variable, so the priority is given to the local variable first. So in order to give the priority to the global variable first, okay, in that case, to make the global variable accessible first, okay, or accessible, if you want to means like display the access the global variable, then we use the scope resolution operator denoted by this colon dot 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 dot. Okay, so the syntax is this. Yeah. So now an example program to demonstrate scope resolution operator to access the global variable and local variable with the same name. So here I have declared here int I equals to 20. So this is a global variable. So I is initialized to the value 20. So I is assigned the value 20. So this is a global variable because it is outside of the main function. Right. Now inside the main function, another variable I is declared. So this and this is different. So this is a local variable. So when the cout statement is run, okay, cout global local variable is, okay, so since it is inside the main function, okay, so this local variable I which stores the value 40 will be call out, and then it will display the output local variable I is 40. Second statement, when we run this cout statement, okay, cout global variable is here, since the scope resolution operator is used, okay, so what will happen is that it will call this global variable, okay, which is outside of this function. Okay, see, that is the advantage of the global variable. It is not inside the function. Normally in the function, be it the main function or function definition, any other function definition, it will only the variables that will only be accessible is the local variables, not any other variables outside in another function body, right? But using the global variable, you can access it anywhere inside any function. So in the main function, provided you use the scope resolution operator, okay, so if you use this dot dot, then you can directly access the global variables and display the value of the global variables also. But however, if you don't use this dot dot, okay, this scope resolution symbol, okay, and you just write global variable I is and then I without using this dot dot, okay, then it will also show the value global variable is I is 40, not 20. Clear? So this is how you can use a global variable using the scope resolution operator. Clear? Next is formal variables or parameters. So formal variables or formal parameters. Now we have already been using these formal variables from the beginning of the function program itself, but we have not used this term. Okay, so now from now, so whenever you do any function program, okay, you always remember that in the function definition, the variables are the formal parameters. So here, formal variable is a list of variables that will accept different types of values. It can accept any types of values, that is float value, integer value, character value, okay, uh, double value, like that, being supplied to the function, that is being supplied to this function by the calling program, by this calling program, right? So formal parameters are declared after the function name and inside parentheses. So within the parentheses, these are the formal variables. They are variables, but they are called as formal variables. Clear? So here, this is the function definition or the call function, right? So in the main function here, you have declared, you have initialized the variable x, which is a float type, 10.0, because it is decimal point, right? Float. So here max and result also float type. So here y is of integer type, which is assigned the value 20. So result equals to max. This is the calling function. Okay, this is the calling function, and here x and y, which are, this is the local variable. So here this function is passing the value of 20 and 10.5 through these variables x and y. So these x and y are called actual parameters, which is in the next slide, which I'll explain. Okay, so here this we can pass this value through this function, okay, within this parenthesis by the variable name. So here the variable stores the value x equals to 10.5 and y equals to 20. So that value is passed to here, to the call function. So the call function, which is of the same function name, of the same data type, float, okay, so it accesses this value, not the actual value, okay, but here a and b, they are the formal parameters. Now if you write here a and b as x and y also, okay, it won't matter, because here, or here, if you write a and b, max ab, that ab, or here if you write xy, this xy and this xy is different, because this is a local variable inside the main function, and here xy, which is being declared here and then accepting the value pass, okay, is a local variable within this function definition body. Clear? So when you are passing this value from here to here, okay, it is accepting a copy of the actual values of 10.5 and 20. That means you are not passing the actual value, you are just passing a copied value of this. Clear? That is something like I say, like I give notes to you, okay, I have the original notebook, okay, what I do is that I Xerox that notebook, okay, and then I pass on the Xerox copy to you. It looks exactly the same, but it is a copied version of my notebook, right? So same thing like that, okay. So this value, okay, the original this original value is stored in this x and y. So what happened is that, okay, when it is passed to these variables or this formal parameter, now they are called as formal parameters, okay. So this is what is called as actual parameter x and y. So when the actual parameter passes the value, okay, in this case here, okay, the value that is passed from here, they are called as actual arguments, okay, and when it is received in here by the formal parameters, they are called as formal arguments, okay. The values, that is 10.5 and 20, will be called as formal arguments in this function definition. So you are not sending the origin value, but a copied value and store it in this variable a and b. Clear? So that means the copied value is in another memory location, not in x and y. Clear? So the copied values are called as formal arguments. Clear on that? Okay, so remember that, okay, this is the calling function, this is the call function or the function definition, which is outside of the main function. So here x and y, they are called as the actual parameters. That means actual parameters means the actual variables, okay, the original variables which is being declared, which is being initialized the value, okay, and you're sending it so that the formula will be executed. Clear? And this is the formal parameters. That means you can call it as, let's say, duplicate variable. Okay, this is the original variable. This is I'll just use the term duplicate for so that you can understand. Clear? And the value that is passed from here, this is the actual argument. This value is the actual argument which is passed to another function body. So that is the duplicate values. You call that as the formal arguments. Clear? So now actual variables or parameters. So actual variables are associated with the function name during function call. That is this one. Clear? When the program calls the call function, so when the program, that is when the control passes on to the call function from the calling function to call function, okay, an argument list is passed to the function through the calling function. So the arguments here, okay, that is the actual argument 10.5 and 20, that is this one, are passed from this x to a and y to b. Okay, so the order of arrangement of the values also matter. If suppose let's say x is float, okay, and y is int, right? Now if you interchange this like this, okay, int b float a. Clear? So that will not match with the passing of the values from float int to int float. Clear? So the order of the type should match from the in terms of the calling function and the call function. If in the calling function the order of arrangement is float int, float type, int type, okay, here also it should be float type, int type. It should not be int type and float type. Otherwise, float to int and int to float, that will result in error. Clear? So here, as I said, a and b are your formal parameters. Okay, so the actual arguments 10.5 and 20 will be passed to here a and b, which becomes what is called as formal arguments. Clear? So the values which is stored in a and b, they are called as formal arguments, and the values which are stored in x and y, they are called as actual arguments. Clear? And since this function definition returns a value back to the, because the return type is float, this function, that means this function returns a float value, so that will be returned back to the calling function, and which will be stored in the variable result, and then cout will display the value which is stored in that variable result of float type. Clear? So go through these four scope of the rules of variables. This is very important. Okay, local variables, global variables, actual variables, formal variables. You have to understand this very nicely. Clear? So if you have any doubts on this, you can ask. Clear?